So we would like to begin section 4.6, which is our section on cryptography, and we'll spend a little bit of time in this. This is an application of the number theory material we've been looking at. So what exactly is cryptography? So it's the study and the practice of securing communication in the presence of third-party adversaries. So it's not only theoretical, but it's also practical, theoretical and practical. So there are people that study the theory behind cryptography, and then there are people that do cryptography, cryptographers that work for often intelligence agencies. And their job is to, develop methods of encoding things and to encode messages. So, for example, foreign governments can't read secret messages sent back and forth. Also, cryptography is actually used in computer communication when you're dealing with, sending your credit card information to a company like Amazon, for example. So when you also send your bank information across the internet to make purchases, cryptography is used to encrypt your credit card information, and then the host would have to decrypt your information. So what is encryption? We've thrown this word around called encryption. Encryption is the process of converting raw information to code so that the information is secure from unauthorized access. So encrypting is encoding the data, putting it into code. And decryption is taking data that's already been encoded, taking encoded or encrypted data and converting it back to raw information, or we might call that the original message. So we want to look at some what are called basic ciphers. So in looking at our ciphers, we're going to focus on just the capital letters, encrypting capital English letters, 26 letters of the alphabet, and decrypting them. So we're going to assign A through Z numbers. We're going to assign them 0 through 25. So A is 0, B is 1, C is 2, and so on and so forth until Z is 25. So we're not going to do lowercase letters. We're not going to do any encryption of numbers. Just the 26 letters of the English alphabet, or you could call it the Latin alphabet, the English version of that Latin alphabet. So we're going to start off one of the most basic ciphers called the Caesar Cipher. The Caesar Cipher. So this is the modern English equivalent of the Caesar Cipher. And it's called the Caesar Cipher because it was developed by Julius Caesar around 55 BC. He would have used it to send his messages across the fields of Gaul. Julius Caesar was a conquering Roman general, and he waged war against the Gauls, and he sent messages, and he didn't want his enemies to be able to read his messages. So he would encrypt them with something called a Caesar cipher. And here it is. Here's the encryption function. I'm going to write down the encryption function. The encryption function I'm going to write in this term. C is congruent to M plus 3, mod 26. So here, C and M are variables. C represents the code, and M represents the original information or the message. So the idea is you take your message and add 3 to it, and then mod that by 26, and you get the code. So what this basically does, it shifts all the letters of, in this case, the English alphabet forward by 3 units. So basically A goes to D, B goes to E, and so on. Now Julius Caesar, he would have done this with his Latin alphabet. So the Latin alphabet, actually our alphabet is the Latin alphabet. We have a few extra letters though. So they had, I think, I don't know, 24 letters maybe? I'm not sure. You'll have to look that up. That's a history question. How many letters did the Latin alphabet have at the time of 55 BC? In any case, we want to see about encoding some things. So example, using the Caesar cipher, using the Caesar cipher, encrypt the message below. The message is, well, since Valentine's Day is coming up soon, let's encrypt the message, I love you. So that is our message. And we want to convert that message to numbers. Message in numbers. Now to convert this over to numbers, we would open up our sheet, which encodes English capital letters to numbers. Now you'll have to have that handy, so you want to have that handy. I'm not going to scroll back and forth to the sheet. I have my own copy besides me. So I is going to be 8. L is going to be 11. O is going to be 14. V is going to be 21. E is going to be 4. Y is going to be 24. O, we already said, was 14. And U is going to be 20. So what we want to do, we want to use the encryption function. So the encryption function says you add 3 and then mod it by 26. So this is going to be the code in numbers. So I add 3, I get 11. Still 11 when it's mod 26. I add 3 to 11, I get 14. That stays 14 mod 26. 14 plus 3 is 17. 21 plus 3 is 24. 24 is still 24 mod 26. I add 3 to 4, I get 7. Now 24, when you add 3 to 24, you're going to get 27. Now 27 is bigger than 26, so when you mod that by 26, you get 1, right? You just take 27 minus 26 to get 1. 14 plus 3 is 17. 20 plus 3 is 23. So there we have our code in terms of numbers. So now we want to do our code in letters. So 11 is, what is 11? 11's L. 14 is O. 17 is R. 24 is Y. 7 is H. 1 is O. 17 is R. And 23 is W. So I love you is going to be Lori Horror. All right, let's do an example of decrypting using the Caesar cipher. So we just encrypted using the Caesar cipher. Now we want to decrypt. Another example, but decrypting this time. Decrypt the message, or let's say decrypt the code. Decrypt the code using the Caesar cipher. Here's the code. OLIH LVJRRG. So I'm going to put my code in terms of numbers. I'm going to go code in numbers. So let's see. O is number 14. L is number 11. I is number 8. H is number 7. L is number 11. V is number 21. J is number 9. R is 1717. And G is 6. Now we want to decrypt. So we need something called the decryption function. So we know the encryption function for the Caesar cipher. What was the encryption function? It was the code is the message plus 3 mod 26. Well, basically we're going to subtract 3 from both sides of that congruence to get the decryption function. Let's make it green. Making it green. When I subtract 3 from both sides, I'm going to get the message is congruent to C minus 3 mod 26. So I'm going to take my code and subtract 3 from my code to get my original message and then mod by 26. So let's see if we can do that. So here is going to be the message and numbers. So subtract 3 from 14. We have 11. 8 minus 3 is 8. I'm sorry, 11 minus 3 is 8. 11 minus 3 is 8. 8 minus 3 is 5. 7 minus 3 is 4. 11 minus 3 is 8. 21 minus 3. 21 minus 3 is 18. 9 minus 3 is 6. 17 minus 3 is 14. 17 minus 3 is 14. 6 minus 3 is 3. And none of those we really had to reduce mod 26. Well, if we got like a negative number, for example, if we had 1 minus 3 and got negative 2, then we'd have to add 26 to that, in which case we get 24, but we didn't have to do that. We didn't get any negative numbers that we needed to reduce mod 26. So if I go back and I convert my message, or convert my numbers to the original message in letters, what do we say here? Well, 11 is L, 8 is I, 5 is F, 4 is E, 8 is I, 18 is S, 6 is G, 14 is O, 3 is D. So our message here is life is good. Life is good. So Caesar cipher is a shift forward by 3, and to decrypt you shift back by 3. Now there's some people that don't like to have a negative number for your decryption function. Sometimes you'll see rather than C minus 3 here, rather than having this minus 3, you'll see plus 23. So let me see if I can write that. C plus 23. Now how did I get plus 23? Well, basically, I'm allowed to add any multiple of 26 to -3, so I decided to add 26 to -3. So -3 plus 26 is 23. So shifting left 3 is the same as shifting forward 23 in the alphabet. Okay, just so you're aware of that. Some people don't like the minuses, they just like pluses. Okay, so in general, we have something called a shift cipher. That's what a Caesar cipher is. It's a shift cipher where you shift forward by 3 units. So a shift cipher, more generally, takes on the following encryption function. Encryption function is going to be of the form, the code is the message plus K, mod 26. And K is going to be a positive integer. C is your code, it's a variable. M is your message. And the encryption key is K, which is your shift forward by K units. Now, usually when you're dealing with mod 26, your K is going to be 1 through 25. You shift forward 1 through 25, depending on how far you want to shift. It could be shift forward 1, 2, 3, like the Caesar cipher, 4, 5, all the way up. That could be 25, however much you want. And we call the key K. That's how far forward you're going to shift. All right, so we want to do some examples of just a shift cipher, but not other than the Caesar cipher. So example, consider the shift cipher with encryption function. The code is congruent to the message plus 19, mod 26. Number 1, decrypt the following: TM, M, TV, DOX, KV, B, G, ZXMH, KBQ. So decrypt that. So I'm going to put this code in numbers. So T is 19, M is 12, M is 12, T is 19, V is 21, D is 3, O is 14, X is 23, K is 10, V is 21, B is 1, G is 6, Z is 25, M is M is 12. Wait. Z is 25, yeah. Z is 25. X is 23. M is 12. H is 7. K is 10. B is 1, and Q is 16. Okay, so that's my code. Now, I want to decrypt this. So let's come up with the message. Can't get this to write right. There we go, message in numbers. So to decrypt this code, I have to come up with the decryption function. It's going to be the message is congruent to C minus 19 mod 26. I'm going to have to subtract 19 from each of the blue numbers. So 19 minus 19 is 0. 12 minus 19. 12 minus 19. Let me get my calculator. It's -7. And then I have to do -7 plus 19. I'm sorry, -7 plus. Let me do that one more time. 12 minus 19 is -7, and then -7 plus 26 is 19. So you do that again. 12 minus 19 is -7. -7 plus 26 is 19. Yeah, anytime you get a negative number, you don't want it to be negative. You want your numbers to be basically from 0 to 25. Remember, 0 to 25. So if you get a negative, you got to add 26 to it. So 19 minus 19 is 0. 21 minus 19 is 2. 3 minus 19 is -16, plus 26 is 10. 14 minus 19 is -5, plus 26 is 21. 23 minus 19 is 4. 10 minus 19 is -9, plus 26 is 17. 21 minus 19 is 2. 1 minus 19 is -18. -18 plus 26 is 8. 6 minus 19 is -13. -13 plus 26 is 13. Let's see. 25 minus 19 is 6. 23 minus 19 is 4. 12 minus 19 is -7. -7 plus 26 is 19. 7 minus 19 is -12. -12 plus 26 is 14. 10 minus 19 is -9. -9 plus 26 is 17. 1 minus 19 is -18. -18 plus 26 is 8. And 16 minus 19 is -3. And -3 plus 26 is 23. So let's convert each of these numbers back to text. So we're going to have the message in letters. So 0 is A, 19 is T, 19 is T, 0 is A, 2 is C, 10 is K, 21 is V, 4 is E, 17 is R, 2 is C, 8 is I, 13 is N, 6 is, let me see, 6 is G, 4 is E, 19 is T, 14 is O, 17 is R, 8 is I, and 23 is X. So what does our message actually say? It says attack. And if you know any history about the wars between the Romans and the Gauls around 55 BC, 52 BC, that time period, you would know who Vercingetorix is, or Vercingetorix, however you want to say it. Vercingetorix, you might hear him called, or Vercingetorix. He was a leader of the Gauls that was defeated. So attack Vercingetorix. So there we have it, an example of a shift cipher. We are actually deciphering.